Hey there, GERO 508, summer 2024. So, this will be module 3 that I'm going to be going over today. All right, so we're starting the second week of classes, which is pretty awesome. Classes go by very quickly. By the time we get done with this second week, remember it's a 6-week class, so you'll be one-third way of your way through completing this semester's GERO 508. Okay, the mind and body connection through the lifespan. So, all right, so we're going to get into it right here. And by the way, today, of course, is June 30th, 2024. Why is that day special? Hey, it's my birthday, all right? We're talking about aging, and I'm an old dude. I just turned 68, all right? So hopefully all you guys will be working all the way until you're 68 just like me. Why not? What else are you going to do with your life? All right, so let's continue on. I'm just going to show you, this is my home page for Brightspace, and you have lots of different choices. Of course, this is summer 2024. This is one class that we're finishing up here, and this is a new one that we just started. So I would go ahead and launch 508. Okay, there it is. The mind and body connection, right through the lifespan. All right, gonna move my head out of the way here. Alrighty, so like I said, we're gonna be doing modules 3 and 4. In modules 3 and 4, again, we're gonna keep building this knowledge base for you, so you have a better understanding of how our stress response system works. Okay, and we kind of went through. We perceive stress, something we see, something we hear. Um, you hear a loud noise and you're immediately, poof, in high alert, okay? Or it can be something that is on your mind, okay? And how we, whether it's appropriate or not, we're tapping into the same stress response that we use for survival when we're out in the wild. Obviously we have evolved, okay, over the last million years, and so we're not being chased by saber-toothed tigers anymore, and yet we still have the same biological system that we tap into when we're worried about being chased by a saber-toothed tiger, all right? Or we're worried about, what kind of job I'm going to get, or can I pay off my car note, or all these kinds of things, all right? All righty, so we're going to expand outward now. We're going to look at, today, we're going to look at some of the consequences in our body's physiology of tapping into the stress system too regularly, okay, a little too often. We call that chronic stress activation. And your body is set up to go into high alert and tear things down a little bit because it's only going to last a little while, and then you're going to go relax underneath a palm tree, have your meal, and you're going to basically cool your jets for a couple of days, but sometimes some people can't turn it off, right? And so we're going to look at what happens when you can't turn it off, both in terms of your body's physiology and your brain, all right? And we learned that from the Sapolsky video, okay? When people couldn't turn it off, or when the study that he did in terms of the baboons, the primates, our relatives, couldn't turn it off because of the social stress that they were experiencing, and how they were experiencing memory deficits, how they were experiencing diabetes, heart disease, okay? Really poor renewal of tissue that needs cell division, okay? For example, your immune system, you produce 200 billion new white blood cells every single day, trickling down from our stem cells in our bone marrow. And if the telomeres are shortened, then you're not going to put out white blood cells, and so you can't fight off infection. And this goes on and on and on. We'll show you a table later on today about these white blood cells. Okay, awesome. All right, so you see down here, this is, the immediate, what to do this week, okay? What's also coming up is, and you got to keep your eye on this, I talked about it last time, is we do have papers due, okay, a paper due, okay, and that's coming up pretty soon. You can either access it over here on the visual table of contents, okay? So we're going to be doing This is my lecture for Module 3. We'll do Module 4, okay? Um, we also, as we come over here, we see the papers right here. So I can access this, and I'm gonna, I could go into the syllabus, but I just want to keep an eye on this stuff and make sure that I know when things are due. And we can see right here is due July 8th, okay, at midnight, all right? Okay, so it's something you got to prepare for, and we've kind of laid it out here. This is a study that you designed. Okay, you just follow the rubric, right? This is what we're looking for: face page, abstract. Okay, um, we need, in total maybe 4 pages. Okay, so it's not that big a deal. You could add on to this some figures. It's okay to go beyond this. Okay, that page limit. We're looking for a minimum of 4 pages. You're going to have a citation page here, so that's going to add maybe a page or two, okay? And it would be great as if you follow these 2 papers as model examples to produce some tables or some figures or some graphs. Again, this is a mock paper, so you're just going to make it up, okay? We're going to talk a little bit today about, a typical study that, for example, that would be looking at either salivary cortisol. It's a way of monitoring how stressed people are, or you can even do drawing of blood or blood cortisol, okay? And then you correlate that with whatever other physiological function you want or psychological state of the sample you're looking at, okay? Now, if you would like to produce figures, I just kind of did a search over here. I said, how do you make tables and graphs in Excel, okay? So there's all kinds of this. I'm in YouTube because I'm very visual. So there's all kinds of, this is a simple one of making bar graphs. This guy does a little bit more in terms of charts. If you want to just say you want to do it individually, I'm just going to delete this, how to make a table in Excel. And it comes right here, and here's how to create a table in Excel. All right, so rather than me go through this, and you can use Google Sheets too, whatever graphical instrument that you're most familiar with. All right, and just if you don't know how to do it, just do a quick. They have these real simple how-tos where people can do a much better job than me, creating an Excel spreadsheet right now. All right, so that's my advice to you guys. All right, awesome. Okay, so we're back here. That was the assignment, okay? And what I'm going to do now is I'm going to go, and again, use these guys as kind of models of what you can do, all right? And when was that due again? July 8th, okay? All righty, cool. All right, so we did module 1 and 2. We kind of introduced, how stress is induced by our psychological state and by just our kind of where we are in terms of social hierarchies and just being social can be very stressful. Are you reading the room right? Are you reading your workplace right? Things like that, okay? All right. Then we talked about a unique part of stress and stress studies and really stress consequences. And then that is how you can actually, through chronic stress, change genes. And one of the big ones, that's my doggies. Okay, they're going outside to go get real hot is what they're going to do. One of the big things is that chronic stress changes the receptors, and receptors are the ones that are monitoring blood glucose. The receptors that exist to monitor, not blood glucose, monitor blood cortisol in the hippocampus, pituitary, hypothalamus. And so if you have fewer of these receptors that we learned about, remember the glucocorticoid receptors, then the feedback loop, it begins to unravel. And so that means your blood cortisol levels stay really high. And so what we're going to see today is what happens when that is the case, all right? So we're going to look at, for example, the connection between mental health and diabetes. And then from mental health to diabetes, mental health to vascular disease, and then you think about, okay, who are the major players in terms of vascular disease and consequences. So we can look at diabetic retinopathy, we can look at diabetic nephropathy. Okay, this is where you get kidney disease because you're stressed out, believe it or not. It all comes together, okay? You can get atherosclerosis to the heart that can result in heart failure. You can, as we'll see, if we look at dementia, okay, Alzheimer's disease is often referred to as type 3 diabetes, and this can be traced back to not only diet and genetics, but also from chronic stress. All right? All right, so that's what we're all about here today. So again, I encourage you can open up a second window in your current browser, or you can also just open a second browser where you can open the quiz, and that way, if you want, you can go back and forth. But there's no right way to do it. You can always come back to it later. These quizzes are not difficult to do. This video is going to go right in here, and this is the reading assignments and videos that you would look at. When you get done with all this, then you're going to scroll down here. You can look at the prompt, okay? And we're going to look at these consequences. So like I said, we understood why we're experiencing stress, okay? It's psychological, and maybe psychological consequently from some type of really strange social situation, okay? And when we have high cortisol, we can see how it can result to insulin resistance, diabetes, okay, obesity, okay, inflammation, heart disease, that on and on and on. We basically want you to kind of do the kind of domino effect and talk about the systematic link between stress and these diseases. Okay, alrighty. So and then we do a little review here on the telomeres and that's really important for the immune system as well. So you check out the prompt. You guys are doing great. Jill and I were checking out your responses last week, and you guys are dialed in. So we're really excited about you as a group this semester. Okay. Alrighty, so go ahead and open the quiz if you want, but we're going to go right in here to Module 3. Okay, all right. So what I do when I can, so we have videos right here. They're pretty simple videos, okay? And so this one starts right here with the consequences of stress, okay? They do, as I go through right here, they talk about the concept of, as I indicated, atherosclerosis. How does this all happen, okay? It's a combination, okay? When you have high levels of cortisol, okay, it causes this massive release of glucose from your liver because you need that glucose for fuel because you're being chased by a lion, right? Alrighty. However, you're not. You're just sitting there worrying, okay? So all that high blood glucose then candy coats proteins, and then the immune system says to itself, well, that looks a lot like the candy coating of the proteins that I see in bacteria, so I'm going to generate an inflammatory response. So now, because of all that glucose that was released, you start getting inflammation, okay? The glucose, if it's not used, gets turned directly into fat, all right? And so now you have tummy fat, all right? You have candy-coated proteins that the immune system's flipping out on, and then what happens is fat has a lot of turnover. Okay, cells die off, they grow, they multiply, they die off, and so your immune system. What we don't realize is it has a huge role in just doing what's calling tissue surveillance. Okay, so it's always doing wound repair. So anytime here I have like a little bruise on my arm. So the immune system is down there saying, hey, we got to fix this. We got to fix the blood vessels, clear out the debris, and put it back to normal. So all day long, you're doing tissue repair from the immune system, all right? So there's a lot of damaged tissue in visceral fat, tummy fat. We call it visceral fat because it lines all the viscera, and it's not supposed to do that, okay? So because it's having cell death and turnover, the immune system is down there just flipping out, okay? Alrighty, the immune system sends out immune system messages that cause a dysfunction in terms of being able to have good insulin receptors. So now, okay, your blood glucose goes up because the insulin receptors are not working as well, okay? That's called insulin resistance. It's not a good thing. Not a good thing, okay? You'll feel really fatigued from it. You'll be peeing a lot, on and on and on and on, okay? Alrighty, so this is the link, all right? Stress-induced atherosclerosis increases the risk of heart attacks, stroke, kidney failure, anywhere the blood vessel goes, blindness, okay? On and on and on, okay? So Another key concept, that's concept one. Another key concept that they talk about this as the Sapolsky, that you'll get a shrinking, even a death of the memory cells in your hippocampus, okay? Um, these guys are always, your memory of stress, memory of everything, but particularly stress. It's going back saying, this is how we dealt with it last time, okay? But as it dies off, then you're not well prepared for dealing with stress that happens in the future, okay? In addition, if you start dying off, killing off the hippocampus, not only that part of your memory is gone, but all parts. So you start showing signs of dementia. It's called cortisol-related dementia, okay? Not a good thing, okay? And then secondly, the decision-making part of the brain, okay? This is your prefrontal cortex, and we talked about this last time as well. So these two areas begin to shrink, they disintegrate. So your decision-making powers also disintegrate because of high stress, okay? And your processing, that your prefrontal cortex works with the hippocampus when you're doing something, working memory. For example, I can go like this, all right, here's my phone, and boom, I just entered my password to get in, okay? And that's my working memory, okay? I'm something I'm working on right now. I know what I want to do. I'm going to check out the waves. All right, so I just brought in Surfline. There it is, okay? How did I know how to do that? Okay, I want to go look at the waves online, okay? There it is right there. So now, this is my favorite website, by the way, guys. And then here it is, okay? And there it is. So now I'm looking at the surf ongoing that's happening down in my local place. How to know how to do that? That was my hippocampus and my prefrontal cortex working together using working memory to get things done, okay? That gets screwed up with stress. Lastly, all right, there is a shortening of telomeres, okay? These telomeres on the caps of our stem cells. Stem cells are cells that have the capacity to bud off a new cell. They remain as a stem cell. They can bud off other new cells, and that new cell then transitions into a functional unit cell, like the specialized cells that last that form the lining in your gastrointestinal system. Okay, like my skin, like my brand new immune system cells that will fight infection. Okay, what happens if the telomeres shorten? Okay, then that is a signal that these stem cells are about ready to go and they start dividing less, okay? And it's not a good thing, okay? That means you're gonna have less renewal in your kidney and gut and have problems, GI problems, less renewal of your immune system, so now you can't fight off infection, on and on and on. In fact, we can look here, I was looking at this, okay? And we look at a bunch of different cells, and this is the turnover rate from stem cells and making new cells. So every 2 to 4 days, we need to have brand new cells put out on the surface. It's called the epithelium of your intestines and your stomach, okay? You see how quickly this is happening. Brand new immune system cells every 1 to 5 days, okay? Brand new, and this shows you how long they last, okay? When it says turnover time, how long these cells last. So they die off and you gotta have new ones put right into place, okay? We can look at our lungs every 8 days. So you can see if cortisol, even something, like a bone cell, it's every 3 months, but you still need good stem cells to produce the brand new functional bone cells that will then lay down the calcium and the phosphate so you have strong bones, okay? So because of stress, these stem cells, again, are beginning to shrink in terms of their telomeres and their shrinking capacity to replace in tissue. All right, important for wound repair, okay? The immune system gets rid of all the bad stuff, and then stem cells divide to make brand new tissue. All righty, that's this video right here. Video number 2. All right, it goes over a little bit more, okay? The effect that stress has on your body. It's a really good video, okay? And it focuses on the stress hormones. So I've been focusing a lot on cortisol, but don't forget we also have epinephrine and norepinephrine. These are released, depending, epinephrine is released out on the body, norepinephrine is up in the brain, also known as adrenaline and noradrenaline, okay? And what we know is that if you have high levels of this, that leads to hypertension, okay? Hypertension, okay? Why is that bad? Any weak spot in the blood vessels, okay, can be sheared off, okay? And now you got damage and inflammation, okay, atherosclerosis, okay? So these two factors, cortisol and epinephrine, can lead to, again, this concept of atherosclerosis. Now, cortisol is directly in there because you remember, it's creating this inflammatory environment because of all the sugar that's being put out there, okay? Also, cortisol, it has a funny effect. It inhibits the immune system, so you think, well, that's anti-inflammatory. Because a lot of us have had cortisol injections in your shoulder or your knee, when you had an acute injury. And yes, it reduces the inflammation locally there so that you get less swelling and less pain, all right? That's for sure, okay? But if you are systemically reducing the function of the one type of cell, a T cell, what is that going to do to your ability to fight off infection, all right? You're going to be in a world of hurt, okay? And that long-term suppression of the immune system actually causes more inflammation because you're infected for longer, you're sick more often, you stay sick, on and on and on. Your wound repair sucks, so you're more inflamed there. You can see it's better to be able to have a spike in immune function and then shut it off versus having low-grade immune function that you can't do anything, all right? All right, so again, it makes you vulnerable to infection, all right? And then this goes over the telomere effect. Now, the telomeres, these caps on the end of our DNA, is a regulator of cell division, but also it protects, it keeps the DNA nice and tight and wound so that mutagens, let's say I had some processed food with a bunch of crap in it that could potentially cause a mutation in my DNA. If I have really long, tight telomeres, it can't get in there. But if you have short telomeres, then you're more likely to have mutations that will lead to cancer. All right, that's what this video is all about. Very, very cool. All right, so now we've made this connection of all the effects, atherosclerosis, the effect on the telomeres. We get in a little deeper here, looking at the hormones, and then on this one right here, then the focus is on diabetes, okay? And just what to remember here in this video right here is that cortisol and stress increases blood glucose, okay? If you don't use it, then that becomes candy-coated proteins that causes inflammation, okay? And also, then what happens is the glucose also, rather than going back into your liver where it's nicely packed, okay, it gets converted into fat, all right? And so then if you get done with your psychological stress and you go eat, then you'll repackage the liver to make all this glycogen reserve, but the fat's there now, okay? So, and this happens over and over and over again, all right? Awesome. Okay, so they talk about the link to diabetes and stress through behavior. Okay, when you're stressed out, okay, especially I mean, we're going to see there's a link between stress and clinical depression. So we can use this basically hijacking of the stress response because we're not having a good day, or because we're not having a good week, month, or because we're clinically depressed, okay? And there's something Julie always used to always say to me that, it is human behavior, but, I eat because I'm sad, and then I'm sad because I eat, And so what happens is one of the quickest ways to get that dopamine lift and get you out of your funk is to eat some really high calorie food, okay? But it's short lasting, okay? And so then you go back and eat more and more. So you make some poor diet choices when you're all stressed out. All right, that's what that's all about. Awesome. So I think my dogs are clicking on the back door. All right. So this right here is, it's okay. It's all good. So this right here is the Healthline article. That is a really, really simple overview of everything we talked about. They didn't go into the mechanisms, but they do tell you about what changes happen, okay, all throughout your body because of elevation of cortisol and also elevation of epinephrine and norepinephrine, okay? So you guys can go check that out. Awesome, all right. And then the last one is a little more technical, and I just kind of want you guys to kind of read this for pleasure, but it does look at the link between this dysfunction in our perception of stress, activation of the hypothalamus that then goes to the pituitary gland. So we're going to need to bring the body on board. So it's the hypothalamic pituitary to your adrenal axis. Okay, remember the adrenal gland, the core releases adrenaline, and the outer shell or the cortex releases the cortisol. Okay, and how when you have disturbance in this is a link to diabetes, and that's what this paper is all about. Okay, you guys go check that out. Okay, this one particular one we have it as a PDF file, and you just kind of go in there like so. All right, like I said, you can either some of the PDF files you are not able to do the arrow. This one I did the arrow. Okay, so it goes over the evidence and how they gathered it. That, oh, look who it is. I want to see this. Come here, little buddy. Where'd you go? He's right here. Wait. It's Desi. That's a good boy. He's a boy dog right there. Yeah, he's a good dog. So this right here is a great form of stress reduction. You have a doggy around. It can drive you crazy, but in a good way. All right. All right. So how do they gather the evidence that suggests that dysfunction in the HPA axis is associated with high levels of circulating cortisol, and that this leads to development of obesity, okay, and that this obesity then leads to further health problems. And so that's what this paper is all about, all right? So they go through everything right here. They talk about what is diabetes, okay? Type 1 diabetes is an autoimmune disease that happens when the immune system inappropriately attacks your pancreatic beta cells, and you can no longer produce insulin. So now you need to have insulin injections. It's consequent to viral infections. Actually, there was believe it or not, there was a rise in type 1 diabetes because of COVID. All right, and the immune system trying to fight off the virus in some people that were vulnerable. It attacked their pancreas. Okay. Then there's type 2 diabetes, okay? And so what happens with type 2 diabetes is, as indicated right here, type 2 diabetes is primarily due to a defect in beta cell secretion, okay? So you're not getting enough insulin, or insulin resistance, okay? That happens for decades, okay? And then what happens is that they can see there's convincing evidence that links visceral obesity to develop insulin resistance. So there's two different levels. What happens is the more fat cells you have and the bigger they are, they release what are called free fatty acids, okay? It's just because there's so much, they can only do so much in terms of packaging, and then they get all screwy and this gets starting to release. So higher levels of these free fatty acids in your bloodstream then, they're going to go back up into the liver. The liver is going to package them as LDL. That leads to atherosclerosis. But in addition, these free fatty acids go to muscle cells. They go to your brain cells. They go all over the place, okay? And what they do is they cause this disconnect between the function of insulin and the way it acts on insulin receptors. So you get this insulin resistance because the receptors don't work as well. Same thing happens. Remember, I told you that fat gets inflamed, so that's the same drill. Okay, so now you have lots and lots of fat cells, lots of turnover because they're sickly and they're dying. The immune system comes in there and starts chewing it up and trying to process it, and it starts releasing hormones saying, "I need more help. We need more immune system." Those are called cytokines. Okay, so some of you may know people, for example, that have autoimmune disease, and you can actually have an infusion of antibodies that will reduce these cytokines, that reduce the inflammatory effect of TNF-alpha. That's a drug called Humira, or reduce the inflammatory effect of interleukin-6, and that's a drug called Enbrel. Okay. Alrighty. So yeah, that's, it's clinically relevant, okay? And there are some clinical trials looking at these drugs to see if they'll help with insulin resistance and diabetes, okay? Alrighty, so that's what that's all about. And then they kind of go over here, this with a normal functioning, okay, brain, all right? Your hypothalamus to pituitary to adrenal axis, okay? It's tightly regulated, it's turning on and turning off the way it should. And then what happens with chronic levels of stress, where you're not able to turn it off, you're not getting the normal levels of secretions. And what happens, we see these links normal. We don't see visceral obesity, but we do see it with dysregulated HPA axis, okay? Fasting glucose, you're a diabetic, okay? Higher levels of insulin because your insulin receptors are not working, okay? Like I said, there's a bunch of free fatty acids out there, okay? So you have high levels of triglycerides, high levels of cholesterol and LDL. So this is permissive towards atherosclerosis. Okay, so that right there is called epidemiology. All right. So then they go through the hormonal control, and they talk about a rare condition that is an example of a dysfunction of the hypothalamic pituitary axis. Okay, and this is called Cushing syndrome. Okay, now Cushing syndrome can happen when you actually have a tumor in your, remember the hypothalamic pituitary axis right here. So if you have a tumor in the P, all right, and it's producing too much hormone that goes down, it's called ACTH, that goes down to the adrenal gland, you have hyper release of cortisol. What do we see in these people? All right, they become obese. They have actually visceral obesity. Okay, they see metabolic effects and changes that look like diabetes. So there is this. Okay, we have this kind of test system, right, that suggests that this is indeed happening. Okay, all righty. Or you can do it in animal models, okay? And then they talk about some of the studies and the way of doing kind of what's called epidemiology, where we can look at things like cortisol in the saliva, okay? And how well it represents the stress response, all right? All right, so they kind of go through this, and this is I'm not going to read through all this, but we're looking at normal releases of cortisol and how that plays out in terms of somebody who has good regulation, somebody else that has poor regulation. All right, and then they go into why we have a disturbed HPA axis. Why? How does this happen? Okay, and they go through the different stages. So this is again of categorizing in a study. So this is the normal function where you have we have a circadian rhythm. So for example, I know that I'm going to need a lot of glucose in my blood when I first get up to get my engine going. Okay, so every single morning we have what's called a rhythmic diurnal change. Okay, it's linked to sunlight and things like that. Okay, so as soon as I'm coming out of my sleep, okay, boom, I get a release of cortisol so that I have glucose that I can use to get going. All right, so this is normal, and they see disruption of this in people that are obese and people that have chronic stress. Okay, they talk about a second stage in their analysis, and this is what you would expect when you have an acute stressor. Okay, I have an exam due. I gotta crank for a couple hours, and then I'm done. That's normal, okay? Then they go in here and they talk about the third stage. Well, this is where you're having frequent repeated stress challenges and what it does, okay? And the big one they're seeing is that we see this again, this down regulation, okay, of the receptors recognizing the stress up in the brain. So that means you're not turning it off. And so if you can't turn it off, then the system has still got the foot on the gas pedal, high levels of cortisol that result to everything we talked about. Okay, immune dysfunction, high levels of blood glucose, okay, that are going to then contribute to diabetes, inflammation, on and on and on. Okay. All right, because you don't have the receptors to sense it, you have poor feedback control, right? So this is what you can either be through the receptors or it could be dying off of the hippocampus or the prefrontal cortex, all right? So they talk about the studies right here, and you can go through that, okay? You can look at the pathological consequences, okay? And it gets into kind of a little more detail than we need, but it talks about the specialized protein that is used to handle triglycerides, okay, and its activity and how that then relates to the development of obesity, okay. And they talk about free fatty acids right here, okay, and how important what the findings are in high stress animals and people in terms of developing the condition of diabetes. So we have genetic predisposition. It is what it is. Okay, so this is nature, and then we have the environmental context, nurture, okay? Something is causing you to be very stressed out, whatever it is, okay? This is going to then result in hyperactivation of the hypothalamic to pituitary, there's the pituitary right there, and then adrenal axis, okay? And the adrenal releases cortisol, okay? Like I said, every morning it goes to my liver and says, give me glucose so I can get going, okay? But it also does the same thing when I'm really psychologically stressed, okay? It then keeps muscle from storing glucose. It wants muscle to burn glucose because you're being chased by a lion, okay? But then if it's all psychological, the end result is you take the glucose that is released here and not used here, and you convert it into fat, all right? So that's not a good thing. You have inflammation right here, okay? And then that is going to result initially in high levels of insulin being secreted, and then what happens is you start getting pancreatic failure, and then because you'll see in type 2 diabetics, they can become insulin dependent because the pancreas fails. All right, awesome. So that's the essence of that paper, all right? I'm gonna end right there, okay? All right, guys, peace on that one, all right? Tell me happy birthday, all right? All right. So, and then get in there and, okay, discuss. Well, it's really important you guys articulate this with your fingers and your brain. Yeah, the more you do it, the easier it is to understand all this. All right, peace. Take care.